Hi students, after knowing about three-phase induction motor torque equations for different torques, now we draw the torque slip characteristics. So in this video, we are going to discuss about the torque slip characteristics of three-phase induction motor. So this is the basically all of you know this is the basic equation for the torque of the three-phase induction motor. Torque is equal to K S E2 square into R2 divided by R2 square plus S into X2 whole square. When you draw the graph where the slip is 0 and from slip is to 1, so you get these characteristics. You can see a straight line like this. So where this is called a stable region of operation of the induction motor. And it reaches the peak, which is called as the maximum value. And then it comes down when the slip goes to the 1, and this is the maximum slip where an induction motor can go into, and then it comes down. So where slip is equal to 1, when slip is equal to 1, what happens? The rotor speed becomes 0. When slip is equal to 0, the rotor speed is equal to synchronous speed. Here you can see the starting torque, full load torque, maximum torque. So here you can see different regions. O to A is called as stable region, which I already said you, and A to B, you can see it is an unstable region. Point A stands for maximum torque and point B stands for the starting torque, and point C starts at the full load torque. So these are the values. So what are the things which you have to remember is when slip is equal to 0, when synchronous speed is equal to the rotor speed, then slip is equal to 0 according to the slip equation. S is equal to ns minus n divided by ns. So this is the equation. So it starts, your torque starts from there, and after that it goes to the starting torque, and then later it goes to the full load torque. And then we discussed about the maximum torque in the previous session, when maximum torque happens. And after going to the maximum torque, it comes down. Actually it comes down, and this is all unstable region. A to B is all unstable region. At B, n is equal to 0, the rotor stops working. So the other way of telling this characteristic is this way. So all of you can compare this image as well as this image. This is exactly the mirror of this one. So as this is very easy to understand, I have drawn this. So this is the right one. So when slip is equal to 1, so all of you can see when slip is equal to 1, S is equal to 1. And when slip is equal to 1, N is equal to 0 actually. So here, this is all unstable region, and this is the maximum torque, and this is all your stable region. What are these dotted lines? Whenever you control the speed, then you get this dotted line. So slip is 0 here. So slip is 0 and slip is 1 here. And slowly it goes to the maximum value and comes down actually. So you can see the ns value. This is the synchronous value. It starts with 0 value here and slowly goes to 1 here. This is based on this equation. Now, after that, there are low slip region and medium slip region here. Torque is proportional to this value. When slip is very less, you can see the square of the very less value is going to be less. So in the denominator, s into x2 square is being neglected. You get this value. R2 is there in the numerator. R2 square is there in the denominator. They gets cancelled. S divided by R2. As R2 is a constant, once we form the motor, the resistance becomes constant. Torque is proportional to S. So at low slip regions, torque is proportional to S. It's a straight line actually. And whenever it goes to medium slip region, so I keep S here, R2 divided by, so R2 I neglected because it is a constant, S x2 whole square. So finally, S gets cancelled, and all the remaining things, let me take it as constant values. So torque is proportional to 1 by S. Torque is equal to K times of X. So it is a rectangular hyperbola equation like this. So here all we have a straight line. As the slip increases, so we have a rectangular hyperbola equation like this. That is how you have to explain the torque slip characteristics. Even if you draw this diagram also, it would be very good. So here this is your operation. This is your normal operation or stable period of the operation, and this is your unstable period of the operation. And from 0 to -1 of the slip, it acts as an induction generator, and from 0 to 1 it acts as a motoring operation. Later it goes from 1 to 1.5, it goes with a braking operation. These are the characteristics, and this is the position where you have the stable operation. This is maximum torque and this is your maximum slip. So with that, we have discussed about from the torque equation, how do you get torque slip characteristics and what are the different torque slip characteristics. We also discussed about when generating mode happens, motoring mode happens, and also braking mode happens. So in this video, we talked about torque slip characteristics where you have to draw the graph and explain about low slip region, high slip region, motoring mode, generating mode, and braking mode. So hope you all like this video. Thank you, everyone.